Good morning, everyone. My name is Roger Oberg. I am with RStudio Marketing, and I'm glad to have everyone here for our latest webinar, Creating JavaScript Data Visualizations in R. Today our presenter is Iwei Jie, who has developed many packages and will be taking us through this particular subject. And with that, let me turn it over to Iwei.
All right, hello everyone. So my name is Yihui, and today I'm going to give you an introduction to the htmlwidgets package that we developed just a few months ago. So first of all, I'd like to explain some background knowledge about this package. So basically, if you want to master this package, you better know something about HTML, CSS, JavaScript, and also R Markdown. And I strongly recommend you to learn a little bit about these things, because otherwise you will not be able to appreciate some interesting things on the web. For example, for HTML, if you don't understand HTML, you will not know what these pictures actually mean. So the body tag, the I tag, and also for JavaScript, it's a very interesting language, and I also strongly recommend you to watch this talk named WET. So it shows some interesting stuff about the JavaScript language. And also, R Markdown is something that we spent a lot of time on in the recent few years. So just keep calm and R Markdown. And so I want to talk a little bit about the motivation behind the htmlwidgets package, which is when you want to use a JavaScript library in your HTML document. The HTML document can be generated from either R Markdown or Shiny. If you want to use a JavaScript library, and you probably can go to the documentation of that library and see the usage. For example, let me use data tables as the example. So if you see this JavaScript library and you thought, okay, this library is pretty nice, and I want to use this library in my HTML documents. And then you go to the documentation and see, okay, how can I get started? And you read the documentation, what's the requirements, what I should prepare in HTML, and how I can include the JavaScript files and the CSS files. And it's a pretty complicated process, right? So you will do a lot of things, like writing the script tag in your HTML document and include the CSS style sheets. And also, if you use R Markdown, if you use an R Markdown document, you need to read the documentation of R Markdown to see how you can include external resources into your document. And then, so in R, normally you get data objects like data frames or matrices, and then you will have to prepare your R objects into like the formats that are useful for HTML documents. For example, if you can convert your data objects into XML or JSON or things like that, and then you initialize this library using another piece of JavaScript code, and you probably will get lost along this process. And our goal of htmlwidgets is that you don't need to take care of all these details. You just write a simple line of R code, and this the htmlwidgets package will just include everything for you. So just to illustrate the complicated process, so when you see a cool JavaScript library, you may be curious enough to try that out, but you may just jump out as soon as you find the water is too deep. And also, for some people, they may not be patient enough to read all the documentation, and copy all the files, and they may just quietly give up when they want to use the JavaScript library. So for the HTML widgets package, we just want you to be really awesome with really low cost. Just a simple line of R code, and you will get a JavaScript library running in your R Markdown documents or Shiny applications. So this package, this HTML widgets package, makes it really easy to integrate JavaScript libraries into your R applications, including R Markdown documents, and you can also use that in the RStudio IDE, and you can even print an HTML widget in your R console, and also use that in Shiny applications. So the full documentation of this package can be found at the website htmlwidgets.org. And if you care about the development of this package, you can go to the GitHub repository. It's in Ramnath's repository named htmlwidgets. So currently we have a couple of authors of this package, including Ramnath, Kenton, and a few engineers at RStudio. So if you want to develop an HTML widget, you need to install this package from either CRAN or GitHub. But I guess most of you will be just the users of the widgets. So in that case, you don't have to know much about HTML widgets. You just install the specific widget packages. For example, if you want to visualize time series data, you may want to consider the digraphs package. And if you want to present your data objects as tables in HTML pages, you just install the DT package. And if you want to draw maps, you may consider this leaflet package. And there are many other HTML widgets packages available, and I will show you some examples later. So as I said, you can use HTML widgets in many cases. So the first one is that you can just print a widget in the R console. So if you print that widget in the RStudio in the RStudio IDE, RStudio will just show that widget as if it were an R plot. So the usage of most widget packages is like this. So first you find that widget package and install that. Then you load that package using library, then the name of that package. So here, widget package is not a real name. It's just a it's just an example. Excuse me. So you load that widget package and you just call a widget function in that package. So let me show you a quick example. So here in RStudio, so I'm using the DT package as the example here. The main function in the DT package is data table, which turns an R object into an HTML table. Excuse me. The data, if you call data table on this R object iris, I suppose everyone must be familiar with this object. So it's just a data frame with 5 columns and 150 observations. So if you print this widget object in the R console, in RStudio, you will see the widget presented in the RStudio viewer. So this just shows the data frame as as the HTML table with multiple pages. So as you can see here, I can show 10 entries per page or more entries per page. So you can navigate through the pages, you can sort the columns, you can just search in this search box. So you can see the usage of a widget is really simple. It's just this one line of R code. But what really happens behind the scenes is that, so we pop this example in my web browser. So you can see the table here, but behind the scenes is actually very complicated. So if you print that widget object in the R console, R will actually, the HTML widgets package will actually copy all these JavaScript libraries and initialize the widget using some predefined configurations. So you can see the source code of this page looks pretty complicated. But anyway, the usage of the widget is really simple. So you don't need to learn a lot about this specific data tables library. You just go to the R documentation and see how you can use that. So that's how you can print a widget in the R console. And then if you got a widget package, you can also print these widgets in R Markdown documents. So the usage is still the same. So now I'm just going to create a new R Markdown document. So file, new file, R Markdown, then document, HTML document. Okay, then I'm going to save this document somewhere. Let's say named untitled2, untitled2.rmd. So this is basically an R Markdown document without the HTML widget packages. So this is just a normal R Markdown document. You can see the code chunks and their output. So to insert a widget into this page, you just do what I just did in the R console. So for example, library dt, then data table iris. And then you compile this document again. You will see the data frame iris presented in on this page as an HTML table of multiple pages. And you can sort the columns, search in the search box. So the usage is still very simple. So that's for R Markdown document. And Shiny. So for every widget package, there will be a pair of functions named something output and render something. If you are familiar with Shiny, you will know that the something output function will be used in the R script UI.R, and render something will be used in the script server.R. So let me just show you an example of a Shiny app. So I'm still using the DT package as the example. So to write a Shiny app, you first load the Shiny package, and I can write the Shiny app using the Shiny app function. So let's because I'm using the data table output function in DT, I will load the DT package, then data table output. Let's say the ID is just full, and then I write the server logic, which is a function with two arguments, input and output. So then I want the output full to be a data table. So I'm using render data table here. Render data table, and the argument for this function is just the widget. So the widget is like data table arrays. So then I can render the table widget just in a Shiny app. So now this is not a static HTML document, it's a Shiny app. So you can see that the usage is still the same. There's nothing else for you to consider. You just call data table iris, and that's all you have to do if you want to embed this table widget into a Shiny app. And as I said, there have been a lot of widget packages developed. And in this webinar, I'm going to focus on only two of them, DT and Leaflet. And in the end of this talk, I will show some quick examples of other packages. So for the DT package, you can find the documentation from the website rstudio.github.io/dt. So this package has incorporated a lot of data tables options into R. So I showed you the usage of data table, iris, and actually there are some other arguments that you can use. I guess the most important argument of this function is options, which takes a list of data tables options. And if you're not familiar with the data tables options, you can find all of them from the data tables website, reference options. And there's a long page of options that you can use for data tables. But what this DT package does is that it provides you a native R interface to the data tables package, so you don't have to write JavaScript code. So, for example, if you're not familiar with JavaScript, you probably don't understand what this object really means. But if you're familiar with R, you will know what an R list means. So, for example, you can initialize the table with some native R options. So all these options actually they will be converted to JSON and passed to the data tables library. So you can start a data table using this data frame as the data and using this list as the initialization options. So basically, for example, if you pass page length equals 5, and that will mean I want to show 5 rows per page. Of course, you can change that. And also the length menu option means I want to customize the menu over here. So I want the possible entries for that menu to be 5, 10, 15, 20. So I can change the length of each page from this menu. And I will come back to these options later. So for the data table function, so we also have a couple of other arguments like callback, row names, column names, container, caption, and so on. I'm just going to walk you through some quick examples. So by default, if your data object contains row names, the row names will be displayed in the first column. So for example, the empty cars is just a data frame in R. And if you don't specify the row names argument, by default, the row names will be displayed. But of course, you can suppress the row names. You can say row names equals false, and then the table will not show the row names anymore. And you can also replace the row names with some new names. For example, I want to display this data frame, but I want to replace the row names with A, B, C, D, E, F. Then you will see a table like this. Then column names, because that's probably not very interesting, so I will skip it. And the container argument. So you can pass an HTML, a fragment of HTML code as the table container. So if you're familiar with HTML, you probably can understand what this these lines of HTML code means is basically a table tag, including a table header. So this is just a custom table header that can be passed to the data table function. So container equals this HTML fragment, and now you will see a custom table header like this. So basically, there's a cell species spanned over 2 rows, and there are some other headers spanned over 2 columns. So this is how you can customize the table header instead of just using 1 row in the header. You can also include the both the table header and the table footer. And again, that's just customizing the container argument. So table caption, if you specify the caption argument of the data table function, you will see a caption in the table, either on the top, or can make that caption show up in the bottom. And now let's come back to the data tables options. So there are a lot of data tables options that you can customize in the table. For example, if you want to sort some columns initially, you can specify, okay, I want to sort the second column, so ASC means ascending, and the fourth column, DESC, means descending. So I want to sort this column in this direction and this HP column in this direction. And let's see. And there are many other options that you can find on the in the documentation of the data tables library. So I'm not going to spend much time talking about that. Then we have a couple of convenience functions in this DT package to format your table. So remember, in the beginning of this talk, I told you that we probably do not want to write a lot of JavaScript code in R. So that's the goal of these functions, these formatting functions. So what these functions actually do behind the scenes is that it will write the JavaScript code for you, so you don't have to know JavaScript. So for example, format currency will format some columns, format them as currency. For example, I want to the columns A and C to be displayed as the dollar amount. So you can format these 2 columns as the currency, and I want to format the column D as percentage. So now D will be displayed as percentages. And these formatting functions also have some extra arguments. For example, when you format the first 2 columns as currency, you can specify the currency symbol. So in this case, I'm using the euro sign instead of the dollar sign. And you can round some columns. For example, I want to round the column E to 3 digits. So you can see now the column E will be displayed in this format. So for the data tables library, one nice thing about it is that it allows you to process your data on the server side. So in that case, so for example, if you search in the table or sort the table or display different pages of the table, these actions can be sent to the server, and the server will receive some parameters from this table and then return the data for the current page. So that's actually implemented in that's actually what was implemented in Shiny. So if you have used the function render data table and data table output in Shiny, that's actually using R as the server side processing engine. So when you, for example, when you navigate to the next page, Shiny will send some parameters back to R, and R will process the data frame and return the data for the current page, so that data tables can render the cells in the table. And another nice thing about data tables is that it has a lot of extensions. But again, if we don't have this htmlwidgets package, we will have to write a lot of JavaScript code to enable these extensions. But now we have the this widgets package, so we can just use these extensions as in this native R syntax. For example, if I want to enable the extension autofill, I just specify the argument extensions equals autofill. So we don't need to worry about, okay, what is the JavaScript file behind this extension? What is its CSS files? You don't need to worry about all these details. You just use this library as if it were an R object. So data table iris2 extensions equals autofill. That will enable the autofill extension, which basically means you can manipulate the table just like Excel. So if you drag this plus sign, it will automatically fill up the column incrementally. And just like the main options for data table, you can use options for all these extensions. For example, I want to specify some options for this autofill extension. I want to disable the autofill extension on the first column and the last column. So 0 means the first column, -1 means the last column. So now if you mouse over these cells, there will not be a plus sign showing there. But if you mouse over the columns here, you will see the plus sign here. So that's for the autofill extension. The column reorder allows you to dynamically reorder the columns. So you can move these columns around. So again, the usage is pretty much native R syntax. Then column visibility, so extensions equals column vis. That will add a button to your table so that you can choose to display or hide certain columns. The fixed columns extension allows you to fix certain columns. So as you scroll horizontally in the table, you will see the first column is always fixed. And of course, you can specify some other options so that you can fix more columns. So now I'm fixing the left 2 columns and the right 1 column. Then fixed header will fix the table header on this page. So for example, if you scroll down this page, you will see the table header is always visible over there. The key table will show a blue rectangle in the table, so you can use your arrow key to navigate through the table. You may feel this is just like Excel. And the responsive extension actually makes the table responsive on the page. So when the page is very narrow, you can see some columns will be just hidden. So when certain columns are hidden on the page, you can click these buttons to expand the hidden information. Then Table Tools is an extension that allows you to copy the table content or save the table as CSV or Excel. You can also print the table. So these are just the data tables extensions. And for every widget package, as I said, you can use them in Shiny. So for the DT package, you basically use data table output in the UI and render data table in the server logic. So I just want to show you a couple of examples that that shows the interaction between data tables and Shiny. So first of all, this is the first example is for the row selection. This is a feature that has been requested a long time ago, but it's just something I finished working just a few days ago. So the row selection example is like this. So when you want to enable row selection in the table, you have to append a special column in the table. So this is a data frame, iris2 is a data frame. I want to append some checkboxes to the table. So append checkboxes is just a function in the DT package. I append a column of checkboxes in the table, so I can select the rows in the table. So this is just a static page, so when I select the rows, there's nothing happening. And here is a live Shiny example deployed to shinyapps.io. So now I embed a data table in this Shiny app using a data table output and render data table. And then Shiny will know which rows I selected in this table. So you can see as I check these boxes, the corresponding points in the scatter plot will be highlighted. And that's because as I interact with these checkboxes, Shiny the DT package will pass the indices of these rows to Shiny. So you can just see the source code here. So for the plot, so these lines of code are for the plot. So when I interact with the checkboxes, I can get the indices of the selected rows from the input object. So input $x1 underscore selected. So x1 is the ID of the table here. So you can see output $x1 is this data table. And then x1 underscore selected will be the indices of the rows that were selected in the table. So once I've obtained these indices, I can add some new points using the indices. So cars square bracket s, that's basically subset this cars data frame using the selected rows. So I will just draw or redraw these points on the scatter plot using a different symbol. So 19 basically means a solid point, and CX equals 2. Basically, I want the points to be bigger, so twice as big as these unselected points. And by default, the checkboxes are added to the last column of the table, and you can also add these checkboxes to the first column of the table. So as I check these rows, you can see the output here will react. So it will print the indices of the rows that I selected in the table. So the source code for this whole app is actually pretty simple. So basically, I have two rows on this page, fluid row here and fluid row here. And for each row, I have two columns. So for the top example, I have the data table output x1 and then plot output x2. For the bottom example, I also have a data table output then x3, then verbatim text output x4. So you can print the indices of the selected rows in the verbatim output here. So that's one example of interacting with Shiny. So another example is as you interact with the table, Shiny will also know the indices of the rows displayed on the current page. For example, now I'm highlighting the points displayed on this page. So if I navigate to the next page, now I'm on page number 2. The indices of these rows will be available to Shiny, and Shiny can just draw some points on the scatter plot using the indices of these pages. And if you search in the search box, for example, I want to match the rows that contains the letter M, so like these rows. If I search in the box, Shiny will also know all the indices of the filtered rows. So not only for the current page, but all the pages. So if I search in this search box, and then I will know the indices of the all filtered data, and I will mark them using the red circles. And this works even if you sort the columns. So for example, if I sort this HP column, which is actually the horsepower, if I sort this column and I navigate through the pages, you can see the first page displays the smaller values of horsepower, and the next page displays the higher or larger values of the horsepower. That's how the data tables widget can interact with Shiny. So that's pretty much what I have got for the data tables widget. And then we have got the leaflet package. So for this, leaflet package is a package for drawing maps. So I'm just going to show some quick examples of this package. So I forgot to mention that both the DT package and the leaflet package are currently only available on GitHub. So if you want to install these packages, you can use the DevTools package and then install GitHub. So for example, if you want to install DT, you can use install GitHub RStudio/DT. If you want to install Leaflet, then you just use install GitHub RStudio/Leaflet. So for the Leaflet package, it's basically the main function is the leaflet function. So this function returns a widget that you can add more layers on. So for example, I create a leaflet widget here, and then I add some tiles on this widget, so that will show me a map of the world. And there are some convenience functions in this package, for example, fit bounds, that will fit this map into a certain bound specified by the latitudes and longitudes. And you can also set the view of this map centered around this point. So this is the longitude, and this is the latitude. And you can set the zoom level of the map. So basically what I'm showing here is where I am. So this is in Ames in Iowa. This is where I am sitting. So the coordinate here actually is the location of the Snedeker Hall, which is where I graduated from. So I graduated from the Department of Statistics the Iowa State University. So for this map, you can add some add a pop-up on the map. For example, I use the function add pop-ups, then specify the latitudes and longitudes, and then the text string to display on the map. Then I'm just going to walk you through some other quick examples to just show you what's available in these packages at the moment. So you can add a vector of pop-ups in some random locations, and you can add markers. So you can see these little icons. You can also add markers with pop-ups. So add markers in these locations, and then a text to show the information about this location. Pop-ups, markers, and then circles, circle markers, which look very similar to circles. And also rectangles, polylines, polygons, and we can also visualize or highlight a county using the GeoJSON. So for example, here I'm highlight, oops. So don't worry about the code here. Actually, all these examples are available in the leaflet package. So you can go back and download the package, and you will find them in the documentation. GeoJSON basically is specifying the latitudes and longitudes of the border of this county. So you can visualize a polygon on the map here. So you can also change different tiles of the map. For example, I'm using a darker theme here, also displaying Seattle on the map. One last thing that I want to show you is that you can also, so as I showed you how you can draw polygons on the map. So one application of that is that you can color certain districts or areas using different colors. For example, here I'm just using the data extracted from the maps package. So for the map states data frame, it basically contains the data about the borders of all the states, and then I can use the leaflet function and add some tiles and then add some polygons specifying the fill color. So that's how this map was generated. So as I showed you before, each HTML page is actually quite complicated, but the HTML widgets will take care of all the dependencies like the JavaScript libraries and these things. So I just want to show you quickly how complicated the source code of this page is. But you don't have to worry about all these things, because the HTML widgets will just render these different pieces of things correctly on the page. So that's the leaflet package. And we also have other packages like digraphs, network D3, 3JS. So I'm also going to show you just some quick examples. The digraphs package can display some time series data using the plots like this. So it allows you to interact with time series data, for example, using a slider on the bottom, so you can choose a time window to visualize the data. So here I'm using the sunspots data. And that's for a single time series. So you can also display 2 time series. So the male death and female deaths in the plot like this. So the main function in the digraphs package is just digraph. You can pass an R object to that function, and the data will be visualized like this. So the next one is network D3 that visualizes the network data of like links and nodes. So this is just a visualization of the relationship among the characters in the novel Les Miserables. So you can see which character is connected to which one. So again, the R code is very simple. The last example is the 3JS package, which displays a globe on the HTML page. So this shows the population of the cities in the world. So it basically shows a 3-dimensional globe, and the population is visualized using these bars on the globe. So just one last comment on the R versus JavaScript visualization. So the main drawback of normal R graphics is that they are not interactive. So once it's drawn, it's drawn. There's nothing else you can do with it. But as the examples that I showed you, in these packages, the widgets are highly interactive. You can choose what you want to do with the widgets. For example, for DT, you can select different pages of the data. You can interact with Shiny. For Leaflet, you can zoom in, zoom out the map. You can add icons or markers on the map, and you can click on these icons, and it will show you additional information. And you certainly cannot do these things to normal R graphics. So sometimes an R plot may look interesting, but if you stare at it long enough, you may feel, oh, okay, that's just it. JavaScript visualizations, on the other hand, is much more interesting. If you have, I strongly encourage you to develop an HTML widget so that your audience will be like this when you show the widget to them. So finally, there are some other resources that you may want to read. So for example, this is a very new article, just written like yesterday or the day before yesterday. So it's a guide to some new packages for data visualizations, including the Leaflet package. So I will just leave this to you to read later on. And another website that is very interesting is this buildingwidgets.com. So the goal was to build 1 widget per week. So there have been a lot of widgets presented in the blog of this website. So you can go ahead and check out the blog posts. And also, I just showed you some silly examples of the Leaflet package, but actually there is a much more interesting example, and I saw that from Twitter just a few days ago. So this guy just did this famous visualization using the Leaflet package. So in case you don't know the background of this visualization, you can go to Wikipedia and read the article 1854 Broad Street cholera outbreak in London. So that's a famous story in history. And this guy just did this in R. using the leaflet package. So you can see the number of deaths in a certain location, and the number of deaths is visualized using the size of the circles. So you can see clearly there's a pattern here. So there are much more deaths in this specific location than other locations. So I just wish Jon Snow had the R language available and also the HTML widgets package available. I guess that will probably make his life much easier in that age. So this is the HTML widgets presenting Jon Snow's map, and I guess that's pretty much what I have got for you today. And if, in case you want to contact me privately, here's my website, here's my Twitter handle, and here's my GitHub account.
Thanks, Yiwei. I want to just make the observation that along the way we had lots and lots of questions, many questions about data tables in particular, so I'm sure we couldn't possibly answer them all, particularly since you were presenting at the time.
Right.
And so we apologize we can't get to all of those questions. There were a couple I thought with the remaining time we might have you comment on. So one question I thought was interesting was, if you're going to create an HTML widget to bind a JavaScript library, do you get everything the JavaScript library has, or does the author curate, and expose only certain things? Is that something the author determines?
It's basically something that the package author decides. So, for example, even for the DT package, I didn't expose everything to the users. So, for example, there's a lot of information about a certain table. So, for example, for Shiny, I only exposed the selected row indices and the indices of the current page and all pages. I only exposed this information to the users at the moment. But if any users request more information in Shiny, I will be happy to do that.
Okay, great. Yeah, so it's author specific, and that makes a lot of sense. Another question I thought was sort of general. A lot of questions about. Yeah, we saw this in Shiny. There were some early questions about whether these things could be incorporated in a Shiny app. You clearly showed they can be. What about other outputs, like using R Markdown or Knitter? Any issues there?
Just as I showed you, there are. Oops. There are 3 ways that you can present a widget. So the first one is that you can print a widget in the R console. If you print that in RStudio, you will see that widget in the RStudio viewer. The second way is that you can print a widget in R Markdown document, and the HTML widgets package will be smart enough to copy all the JavaScript dependencies and CSS dependencies into R Markdown. The third way is Shiny. So I'm not sure if that's clear enough.
That sounds very clear to me, and I think it just wasn't clear to everyone along the way. And last question that I think we have time for that I'll pose to you is that if you're creating an HTML widget, and you showed us some websites to go to learn more about that, but any sort of basic advice for those that might have joined the call and hope to hear a little bit about how to create such a widget?
Yeah, there are some convenience functions in the HTML widgets package, like create widget, or actually there's a okay. So you can see my screen now, right?
Yes.
Okay. So HTML widgets. If you want to write a widget, there's a button on the bottom of this page, develop a widget, and you can go through that tutorial.
Fantastic. Thanks for that pointer. Okay, and then I think that's all that we have time for. People are asking if they're going to be the slides are going to be available. Yes, as mentioned at the beginning of the call, everything that we have shown today in the examples will all be posted within 48 hours on our website under the webinar tab. So if you go to resources, you'll see webinars and you'll see the full content. Do give us a day or so to get that up, please. It takes a little while to assemble everything. But we'll get it up there so you see this again, pause where you feel appropriate. We'll close out today. Just if you're not aware, we would love for anyone interested in our commercial products to take a closer look. This is how we support the business, and we appreciate your interest in first of all, we appreciate your use of our free and open source products. It's exciting to see what the R community is doing. And for those for whom it is interesting and they're starting to see deployments get scaled up in their organizations, it may be that our commercial products have some features that will be useful to you. We'd love for you to evaluate those. Please stay in touch. We look forward to seeing your applications on shinyapps.io with HTML widgets in them. Thanks very much, everyone.